Today we're going to talk about some of the terminology and symbols that you'll see and come across in probability and when talking about sets of data. So first we're going to talk about the intersection and the union of sets. So the intersection, we use this upside down U symbol, and the intersection means all of the elements that belong in more than one set, or in both sets in a case of just two sets. And the union, which is just that we use a U for union, represents all of the elements in each set. So basically it's the elements in both sets put together. So let's see how that looks visually. So if we have a Venn diagram here, so a Venn diagram is this, let's say this circle here represents set A, and this circle here represents our set B. The intersection is going to be the part of our graph where A and B intersect. So it's going to be this inside portion here. So this inside portion of this Venn diagram where the two are overlapping represents the intersection. So this is the intersection for our graph, or for our set, intersection. And whatever elements exist in the intersection are going to be contained in both the sets A and B. So that's the intersection. The union, so if we again have sets A and B here, the union is just all of the elements in A. So we have all of our elements here. So this is the set A, and that's everything in A there. And then everything in B here. So the whole circle for B here. The union is just everything. All of the elements in A and B all put together. So this whole thing, that whole thing is the union of the two sets. So the union contains elements that are just in A, elements that are just in B, and then also elements that are in both A and B. And that would be the union. So let's take a look at how we can represent the intersection and union of sets when we're actually given two sets that contain numerical values, right? So mathematically, how would we talk about this? So we have the set A that contains the elements 1, 3, 5, and 8, and then set B contains the elements 3, 5, and 7. So first we want to find A intersection B, the intersection of A and B. So when we talk about intersection, what we're talking about is what elements are in both A and B. So intersection means and then we're going to find the union, which is A or B. Now this is not a, when we say or, we don't mean that it's in one or the other. It's not exclusive. It could be in one or the other or both. Okay, so let's find the intersection, A and B. So we're looking for elements that belong in both A and B. So we're going to use this set. So 1, is 1 in both of these? No, so we can't use 1. 3, yeah, we see a 3 in A and we see a 3 in B, so it's going to be in its intersection. 5 is in A and in B, so that's also in its intersection. 8 is not in both. 7 is not in both. So the intersection of A and B are just the elements 3 and 5. And then let's find the union. So the union is just all of the elements in both sets put together. You don't need to list them twice. If an element repeats, you just list it once because it's represented in this set and it only needs to be represented once. So 1 is in A, 3 is in both, but we again only write it once. 5 is also in both. 7, right? We have 7 here. And then 8. So this is the union of A and B. So it's the elements that are in both A or B, right? So there are some that are just in A, like 1 and 8. And then there are some that are just in B, like 7. And then there are some that are in both. 3 and 5 are in both A and B. And so the union just represents all of our elements in both of them.